Now this video is going to be a supplement to video 4.8, which was a demonstration of a complete factor analysis that we pretty much did from scratch. So we're going to use the same made-up data, this simple data set, and I'm going to show you on Stata how to do a factor analysis. So first, what we want to do is open up the data editor, and we're going to enter in the information. So we had six people, and they had scores on 3 different areas: verbal, math, and logic. Our first one, let's go to edit mode. Sorry, first one had 8, 12, and 16, and then 6, 10, 20, 5, 4, 9, 5, 10, 15, 4, 16, 20, and then the last one was 2, 8, 10. As you notice here on the left in the command section, Stata knows everything that I'm doing. So we want to change the names of these variables: variable 1, variable 2, variable 3. Down here you can change it, or I'm going to actually open up a do file. I already have it up. We can enter in the data in the data viewer and then rename the variables in the window, which I just showed you here, or by the commands. The commands are this. You can rename, var1, we're going to rename it verbal, rename var2 math, and rename var3 logic. So let's highlight these 3, see if it works. Hit execute. As you see, it changed here. So that's all we need in the data editor to see there. We then can run factor analysis. And the code that we're going to use for that is pretty simple. You just type in factor, and what are the variables we want to run? We want to run verbal, math, and logic. And we want to add some options to that. So next we're going to type in min eigen parenthesis 0.08, and then PCF. Now PCF stands for principal components factoring, which is the kind of factor analysis that we're doing. What I'm going to add in here is factor, I think it's factors actually, and then 2, which means, actually if I don't put that in, it's going to tell me that we have 3 factors on here, but in the video that we did on this, we only did 2 factors, and I want to specify that and just leave it at 2. So when we run this, we look over here to the side, and 2 tables appear in the output window. The first table contains eigenvalue information. So we can see eigenvalues here for factor 1, 1.97, factor 2, 0.887, factor 3, 0.14, and it'll just go as many factors as we have variables here. But if you look here in retain factors, it only retains 2. So the second table contains those factor loadings on these 2 factors, and we also have a column of uniqueness, which is default in Stata. So these are the 3 factor analysis results selected by Stata to form the default condition for output. We have eigenvalue information, loadings, and uniqueness values. The loadings are all one actually needs in order to create the complete factor analysis summary table as we did in the video on this. From those factor loadings, we can compute uniqueness and communalities and eigenvalues and all that good stuff, including percents of eigenvalues. So notice how simple the Stata commands are. all we did was factor, type in our variables, and then we added a few options after that. But if we didn't add the options, the factor analysis would still run complete if the default settings were sufficient for what we needed. But following the comma here, this what I added min eigen 0.08 is the minimum eigenvalue criterion. And we specified it to 0.8. Usually we don't go lower than 0.1 because of the eigenvalue less than 1 criterion, but for this case it was necessary because with the unrealistically small data set, the second factor only has an eigenvalue of 0.887 as you see here in the output window. Now let's obtain a rotated factor pattern. This is also pretty easy. Let's just do a rotation. All you do is type in rotate, and for this one we need a comma and just need to let Stata know what kind of rotation we're doing. We're actually going to do a Varimax rotation. And let's run that. Okay, so the output from this additional instruction includes a first table of variance accounted for by each factor. We see here the variance accounted for by factor 1 is 1.79, factor 2 1.06. And those are analogous to eigenvalues that aren't shown. And then we have a table of rotated loadings and uniqueness. And note that the uniqueness values don't change from the unrotated. I'll show that here. So the uniqueness is the same in both. And as stated in the video about factor analysis, that this is a supplement to, that will always be true. The uniqueness will never change when you do a rotation because the rotation does not change the amount of variance in each variable accounted for in the space of m factors, in this case 2 factors. It just changes the rotation of axes within that space. For me it's easier just to understand that what rotation is for is it's something that simplifies interpretation. So as we see here, it's when we rotate a vector plot, or in this case, just using Stata, when we rotate these factor loadings, it's easier to interpret what loads onto what. From the first one, we can kind of see that math and logic go with factor 1, but so does verbal. And we see that verbal goes with factor 2, and math and logic don't really at all. But upon rotation, it's even more explicit, and we know that math and logic go with factor 1, and verbal does not. And verbal goes with factor 2, and math and logic do not. So it's just, rotation is just easier for interpretation. So that's how you do this on Stata. It's pretty simple. Hope you enjoyed it.